Again, the instructions are to find all real solutions. Here, we'll try and factor, but you can't factor. I already know that. So what we're going to do is write down our P's and Q's. That's the first thing. So P, remember, is all the factors of this, and they're always plus and minus, and it always starts with 1, plus or minus 2, because 2 goes into 24, 3 goes into 24, 4 goes into 24, 6, 8, and I'm just still like think what times what is 24? 8 times 3, 2 times 12, and then 1 times 24. And it's always plus and minus. Okay, that's P's, easy. Q, that's all the factors of this. This time it's different. We have plus or minus 1 and also plus or minus 3. Now I want all combinations, all possible combinations for P divided by Q. So that just means all of these things divided by 1, which just gives us all of those. So I'll rewrite all of those. But then all other combinations would be plus or minus 1 divided by 3, plus or minus 2 divided by 3. I'm just taking this and dividing it by this. I did that here. They just all came out to be the same thing, just because 1 doesn't change that that number. Plus or minus 3 divided by 3. I don't need to write this because this is the same as 1. So I'm just not going to write that. Hopefully you caught that part. And then plus or minus what? 4 divided by 3. 4 divided by 3. I'm just taking this and dividing. And then I'll take this and divide. This and divide, and so forth. So then I'll have plus or minus 6 divided by 3. That's 2. That's the same thing as 2, so I don't have to write that. 6, 8 divided by 3. Plus or minus 12 divided by 3. What's 12 divided by 3? That's 4. I already have that. I already have 4. So I don't need to write that. And then plus or minus 24 divided by 3 is 8. And I already have that. So really, those are all the possible combinations. Now you're thinking like, holy smokes, I got to check all of those? Potentially, you have to check all of them. But once we get one of them, then we can factor with our normal methods because this is a cubic function. Whoops. A cubic function. So let's just try. Let's just start trying. And we're going to use synthetic division. So I'm going to test things out. So I'm going to test my first thing, negative 1. I'm going to test x plus 1. Wait, you just said negative. Well, remember, it does turn to a negative 1 when it's out there. So I am testing negative 1, but I just test x plus 1. That's the factor that I'm testing. And then I write the coefficients, 3, 2, 1, nothing. Okay, so I don't need a placeholder. 3, 1, negative 38, and 24. And sometimes it takes a long time, like this example you saw on the sheet. It takes a little bit, but synthetic division is really fast. So what is that? Negative 3, negative 2, 2. What is that? Negative 36. That'd be 36. That adds up to something that's not 0, so this does not work. So first test doesn't work. So I'll test something else. What about? And I'm just doing it in order. That way I don't miss any. So I'm testing positive 1 now. Same coefficients, and you just keep going. It's kind of relaxing. No, it's not. Yes, it is. Well, to me. So then 3, move that down, multiply. 3, 4, 4. What did negative 34, negative 34. That doesn't work. I want a 0 right there. That's how I know that these things are factors. Right now, this is not a factor. That is not a factor. Now I'm just going to keep testing. I did plus or minus 1. Now I'm on to 2. So test x minus 2, which is the same thing as a positive 2 out there. And then again, same coefficients. 3, 1, negative 38, and 24. And I'm just doing it in order until I get something. 3, 6, 7, 14, 8, that's 4, 3, 2, negative 24, negative 48, negative 24. That's not a 0, so this doesn't work. And I'm just going to keep going. I think it's important that you see that, yeah, it doesn't happen the first time all the time. We just got lucky in that first example. So I'm testing negative 2 now. what was it? 3, 1, negative 38, and 24. It takes a lot of patience to do these problems properly. Sometimes you get lucky and get it on the first try. What would this be? Negative 6, negative 5, 10, negative 28. Definitely not going to be, it's not going to work out. Nope. So, like, yeah, I already know, because this is going to be positive 56. It's not going to work out. Okay, well, I did those 4. Now moving on to testing x plus 3, which is the negative 3 case. And let's see. 3, 1, negative 38, and 24. 3, that's negative 9, negative 8, positive 24, 3, 2, 1, is that right? Negative 14? I don't know how to do math. What is going on? I know it's not going to work because that's not going to be 24 over there. So I know that's not going to work. So I'll test x minus 3, which means I'm testing positive 3 over here. And that'll be 3, 1, negative 38, and 24. So if I get the 3 down there, and that's 9, that's 10, that's 30. That's negative 8 there. 3 times negative 8 is negative 24. Look at that. We got ourselves a winner here. Alright, now you've forgotten like what we were doing, but this one works. So x minus 3 is a factor, and I rewrite it. And then I have my constant, my x squared. So this would be 3x squared plus 10x minus 8 at equals 0, and I can use my big X. 3 times negative 8. I cannot use the shortcut on this one, so careful. And then 10 in the bottom. What is that? 6 and 4? 12 and 2. 12 and negative 2. So, how do I not use the shortcut? Well, I know that I'll have the x minus 3 eventually. So 3x squared plus 12x minus 2x minus 8. Split it up. I can divide by 3x. 3x on the outside, x plus 4. When the first term is negative, I divide by negative. Whoo, just cruising through this. Plus 4. That works. That works. And so, really, I'm going to take that way over here. So, x minus 3 times x plus 4. Right, from there. And then the leftovers, 3x minus 2. And that all equals 0. I can set each piece equal to 0 and solve. I get x equals 3. I get x equals negative 4. And some people might be confused about this one, so I'll just set it equal to 0 and solve. I mean, I could do it in my head, so could you, but this is why it is what it is. 2 divided by 3 divided by 3. X equals positive 2/3. So we have 3 answers here, and that's what they are. Let's review the steps real quick. Write out all the factors of P, write out all the factors of Q. Those combinations, when you divide them, those are your guesses, and then start testing with synthetic division. Doesn't always work the first time. Once you do get something that works, you know it works if you get a 0 remainder, then you can write it in factored form, and then just factor the rest of it. And then there you go, factor the rest and solve.